Alright, now up to this point we haven't really done anything that was overly hard or difficult. So I think I'd like to do at least one of those before we move on to do something else. Alright, so this one we're going to integrate 2 minus the sine of x squared. Now what makes this one difficult is the fact that we're going to have a quadratic here, right? Because we can't just distribute this squared, so we're going to FOIL it out. So we're going to have 2 minus sine of x times 2 minus sine of x. Now we can't just take the integral of it as is because the function inside is not linear. We don't have a rule for when it's linear. I didn't include those up here, but hopefully you notice that for each of those it was just 1 over a, right? And so hopefully we'll be able to get through just recognizing that. So if we go ahead and FOIL this out, we'll have 4 minus, and they'll have a minus 2 sine of x there and a minus 2 sine of x there, which makes minus 4 sine of x, and then negative times negative is positive sine squared of x. Now, of course, the problem here being that we haven't done a quadratic sine of x yet. And so I present to you something that we've actually done before, which is this, with the double angle formula. Now what the double angle formula will allow us to do is convert it from being a squared to being something similar to this double angle. So really I want to get sine by itself. So what I'm going to do is take the double angle formula related to sine squared of x, and let's rewrite it. So I'm going to have cosine of 2 theta is equal to 1 minus 2 sine squared of theta. Let's solve for sine squared. We're going to subtract 1, so that will be negative 1 plus cosine of 2 theta equals negative 2 sine squared theta. We'll divide both sides by negative 2, and then we'll have 1/2 minus 1/2 cosine 2 theta equals sine squared of theta. Now in the book they just say, here you go, it's magic, here's the equation. But I want you to know that this equation would not be given to you on the IB exam, nor will I allow you to just pop out and use it. You need to know that it actually came from this double angle formula, which is given to you on the IB exam. So what we can now do is replace that sine squared of x with this. And so I'm going to rewrite it now as 4 minus 4 sine of x plus 1/2 minus 1/2 cosine of 2 theta. Now, of course, this is the original function, and so what I want to do is now integrate it. So I'm going to find the integral of all of this. And so I'm going to go ahead and use that property that allows us to break it up. So I'm going to go the integral of 4 dx minus 4 times, because I can put the constant in front, remember, sine of x dx plus the integral of 1/2 dx minus 1/2 integral cosine of 2x dx. I know I wrote theta there, but we're dealing with x, and so it really should not be a theta here, it should be an x. Alright, so from this point we can actually take those integrals. The integral of 4, integral of a constant, should then be 4x minus 4 times the sine. Now the sine of x will give me the negative cosine of x, so negative cosine of x plus 1/2 x, right, because that's a constant, so constant, minus 1/2. Now the cosine of 2x. Now I know that the derivative of the cosine is the sine, so that's sine of 2x. But then remember that if I have a linear function, ax plus b, which is inside of that cosine, then the derivative is actually going to be 1 over a times sine of ax plus b, right? So I have to have that 1 over a like I mentioned before, so I'm going to need that 1 over 2 again. Alright, so we can go ahead and simplify this, and we're going to rewrite it I've got 4x plus 1/2 x, so I'm going to write that as 9 halves, because 4 is 8 halves, plus another half would be 9 halves x. I'm going to change this to plus 4 cosine of x, and then I've got plus 1 over 4 sine of 2x. And then, of course, plus the c. Don't forget the plus c, like I almost did. And so there you go. We are done.